Okay. Um, so the first chapter is called equations and inequalities. We're going to talk about the methods to solve equations and inequalities, including I think linear and quadratic equations and inequalities. The first section will be linear and absolute value equations. Everyone knows how to solve linear equations, but the absolute value equations are a little tricky. You probably didn't learn this before, so this course covers a lot of topics, in depth. Uh, I think I talked about that last time. So you're gonna see it from time to time, but most of the time, uh, the the topics might have been covered in intermediate algebra, but the depth is not so so much. So you probably see some challenge when you take this course. Okay. Don't be afraid of it and don't be frustrated. That's pretty normal. Okay. Let me just close my email. Some people is trying to send me emails. Okay. All right. So let's talk about the linear equations first. So a linear equations is an equation in the form of ax plus b, where x is a variable to solve and a and b are constants. Okay. So to solve a linear equation, what you do is just separate the variable with the constants, and then do some simple algebra to divide. For example, to find the value of x. Okay, for example, if you want to solve the equation of 5 times x minus 4 minus 7 equal to negative 2 times x minus 3, then you can simplify the two sides of the equations separately. So 5 distribute to x negative 4, you get 5x minus 20 on the left, and then you distribute negative 2 on the right side, you get negative 2x plus 6. Remember, negative 2 times negative 3 is positive 6, right? Okay, and then you just flop or flip around the terms. You put all the terms with the variable on one side or all the numbers, the constant, to the other side. So if we move negative 2x to the left hand side, you get a positive 2x. So when you move to the other side, you change the sign. Another way to understand it is to add 2x on both sides. So then you get plus 2x on the left and negative 2x plus 2x. They get canceled. Similarly, you can add 20 and 7 on both sides. So, you get everything canceled on the left for those parts, but then on the right, you got the 6 plus 20 plus 7. And then you just combine like terms, each side, 5x plus 2x, you get 7x, and 6 plus 20 plus 7, you get 33. And then you divide by 7 on both sides, you get x equal to 33 over 7. So I think that's a easy example that everyone knows how to do it. I'm not spending too much time on this thing. Any questions? No question. Let's go to the next page. All right. Okay. The next example is still a linear equation, but this time we got some fractions. Okay. I know a lot of people have problem with fractions, and it's pretty challenge for a lot of people. There are different ways when you have fractions in an equation. There are different methods to solve it. You can either do the same thing as we did in the previous example by combining like terms with fractions, moving around the terms to store it. That's one method, but a more frequently used method is to actually get rid of the fractions first. And that makes it a little easier or clean for the process. Because once you get the fractions cleared up, then everything is just integer, and then it's more straightforward. So in this example, we need to add 230x 2/3 x plus 10 minus x over 5 equal to 36 over 5. So we got the 3 fractions in here, and the denominators are 3, 5, and 5. So let's just do it in a clean way, as I just said. So I'm going to get rid of all the fractions first. And to do that, I need to find the least common denominator of the 3 fractions. So you look at the denominator, there's 3, 5, and 5. So how do you find the least common denominator? Does anybody know what the least common denominator is? Any volunteers? Well, you just multiply the denominators without repeating. Okay, so you multiply 3 with 5, but you don't multiply the other 5 because it already appears in the second place. So the least common denominator is just 3 times 5. So that's LCD, which is 15. Okay, then you multiply 15 on both sides of the equation. All right. And to do that, you need to distribute 15 to each term on both sides. So you're going to get 15 times 2/3 x plus 15 times 10 minus 15 times x over 5 equals 15 times 36 over 5. Okay. So here comes another problem. How do you multiply fractions? How do you multiply 15 with 2/3? Anybody knows how to do it? Nobody? Well, let me just remind you, class activity is one part of the, grade. So please to be active in the class, because, I want to know how much you actually learned, how much you know about this. And that's important for both of us, right? Then I can go proceed. Okay, so there are 2 different ways to multiply 15 with 2 or 3. You can rewrite 15 over 1 for 15 times 2/3. Then you just multiply top by top and bottom by bottom. So you get 15 times 2, you get 30. 1 times 3, you get 3. So 30 over 3 is 10. So we got 10x from the first term. So that's one way. But there is an easy way to do it. Well, 15 will come up on the top and 3 at the bottom. So you can actually cancel 3 from 15, you get 5. And then 5 times 2 is 10. So again, you get 10x, right? Isn't it? Okay, so that's the first term. The second term is 15 times 10, you get 150. Okay, that's easy. And the third term, 15 minus times x over 5. Again, if you do it in the easy way, 15 comes on the top, so you can cancel 5 from 15 you get 3, so you get negative 3x from that term, and on the right side, you can do it again. 15 cancel 5, you get 3. 3 times 38 is 1. 36 is 108. Okay. So you can see, in this case, it becomes a little clear that it makes it much simpler for you to cancel first before you multiply. You can actually multiply 15 with 36 and then divide by 5. And you also get 108, but that is not so straightforward as the method of cancellation first, right? Okay, so we got those terms on both sides, and just flip around. Let's just subtract the 115 on both sides. So get 10x minus 3x equals 108 minus 115. So then that becomes 7x equals negative 42 if you do it. So lastly, you just divide by 7 on both sides, so you get x equal to negative 6. Negative 42 over 7 is just negative 6. So that's the final answer. Any questions? No question. Then we'll go to the next page. Well, I want to make sure everybody is following me, and uh, you know, just interrupt me anytime when you got any questions or any comments. So that's the second example. Let's just do a few more. Okay. So we just solved the two examples of linear equations, and we got the answers. Okay. Sometimes when you have some equations, not just linear equations, for all the equations, you could have one solution or multiple solutions or a few solutions from the equation, but also sometimes you may not get any solution, or sometimes you will get the infinite many solutions. And then we have different terms to call these different situations. Okay, so we call an equation a contradiction if you cannot find the solution, if there is no solution for the equation. Okay, so that's completely contradictory. If you get one or a few solutions from the equation, then we call this equation conditional, because the equation holds in the condition of those few solutions. Okay, it doesn't hold for any other values of x. So that's condition. And then last thing is called identity. If the equation always holds no matter what the variable x value is. Okay, so that's called identity. It's always true. So this is opposite to contradiction. In the case of contradiction, it's always untrue. The equation never holds. In the identity case, the equation always holds. It's always true no matter what the x value is. Okay, so you get infinite many solutions in this case. So let's just see a few examples about those situations, three different cases. In the first example, we just solve the equation of 2x plus 1/3 equals 6x plus 1/3. So again, we got some fractions in here. So we can, break up the numerator on the right side to start. Okay. One of the things I want to remind you is a lot of people would cancel 6 with x on the right side, 6 on the top, 3 at the bottom. They would cancel them, and that's not right. You can never cancel it before you factor the top or bottom. And the other way to do it is actually break or split the terms on the right side based on the numerator. Okay, if you cannot factor anything. So like in this example, we can split the terms on the right into 2 with the same denominator 3. So you don't change the denominator, but you do break up the numerator into 2 so that you get two fractions. One with 6x/3 and the other 1/3. Okay. And then you can simplify 6 with 3, you get 2, cancel them. So now you can cancel it. See? So on the right side, we get 2x plus 1/3. But if you look at the left-hand side, it starts from 2x plus 1/3 also. So you see exactly the same thing. And that really doesn't matter what the x value is, because they're always the same. You got 2x on both sides. So, when you change the value of x, that they're always the same. So 2x plus 1/3, of course, is always equal to 2x plus 1/3. Okay. So that's a identity. It is always true. Right? Any questions? No question. Then let's just do one more example. Now we need to solve another equation. We already did quite a bit. Let's just do one more with more brackets or parentheses. This makes it a little more complicated when you have all these terms with brackets or parentheses. You always start from the inside. Okay, so we get 4 times 2x minus 5 times x minus 3 equals 6. Okay, so the inside part is 5 times x minus 3. So you need to distribute 5 or negative 5 in this case, actually. So negative 5 distributed to x and negative 3, you're going to get the negative 5x plus 15. Negative 5 times negative 3 is positive 15, right? So then you combine like terms inside the bracket on the left. So 2x minus 5x, you get a negative 3x. And then you still have 15 left. Now you got the 4 times these two terms, so you distribute the 4 to both of them. So you get the 4 times negative 3x, which is negative 12x. And 4 times 15, you get 60. On the right side, you get 6. You got 6. So now, move 60 to the right, it becomes negative. So 6 minus 60, which is negative 54. And on the left hand, left-hand side, you just get negative 12. Now, to solve for x, you just divide it by negative 12 on both sides. So negative and negative cancels, so you get a positive 54 over 12, which can be simplified. How do you simplify it? You can factor 54 by 9 times 6, and you can factor the denominator 12 by 2 and 6. So you got the same common factor 6 that can be canceled. So the final answer is just 9 over 2. So we get one solution from this example like we did before. So this is called the conditional equation. So this condition holds conditionally when x equal to 9 over 2, the equation is true. So that's a conditional equation. It's not always true. The statement, the equation is not always true. It is true only when x equal to 9 over 2, but you do get some values of x to satisfy this equation. So that's conditional. All right. Okay, the next case is called the contradiction. I think we're going to stop here. We're going to do it next time. Now let me just stop the material, and we'll try to test the Zoom, see how it works. Any questions before we, end this part? No? Okay. Let me just give you the code. Okay. First for the Zoom, I need to open my Zoom. Okay. Wait a few seconds. Bear with me for a second. So I just logged in my university account with SSO, and just open the Zoom. Okay, you might want to write down the code for my Zoom number. So I'm going to schedule a meeting today from 1:30 to 2, or anytime, maybe 1 hour. It doesn't matter. We just test it, so it doesn't take too much time. Okay, you need to write down this code or meeting ID is 207-491-6257. You get it?
Can you repeat it?
Yes, I can. You can hear me, can you?
Yes.
So I'm going to uh, put it in the, you know, uh, on the chat
Chat.
window. So this is a Zoom code. You're going to use 207-491-6257. So I'm not going to close this, Blackboard Collaborate in case there is some issues, then we can still communicate with Zoom. But I'm going to log into Zoom and try to, do it. So I just scheduled the meeting. So what you do, you just what? You just uh, click on the Zoom button or app in your university account. When you log into the university account via SSO, you're gonna see all those things, Blackboard, Bulldog, what? Uh, or banner or Zoom, you see all of those things. Click on Zoom and open it, and then put this code in the ID. Then you should join the meeting, right? Okay.
Okay. I'm doing it right now.
Yeah. Let me just sign. I'm going to do it with my iPad instead of the computer because I want to make sure it works when we have the class in campus, on the next Wednesday. So, is everybody following me? And I know, Kishan, you are, but I didn't hear anything from Judin. Are you still here?
Wait. Yes, I'm still here.
Or are you Judin or Kishan? Or are you Kishan, right?
Yes, Keyshawn. I'm joining right
Yeah,
now. I'm putting in the code.
yeah, yeah. I don't see any, I don't see uh, Jadin responding me. So I need to join my Zoom from iPad. Let me just do it. So I need to log into my account again. Via SSO to the university account. Did you? Are you able to join the meeting in Zoom, Kishan?
We're both on Zoom already.
Yes, we're
Oh, did you? So you already joined them?
Yes.
yes,
Oh,
we're
great.
on,
I
but
mean,
you're not on.
so- yeah, Jaden, I mean, you're still here. I'm glad to see. So I'm going to log in myself now. Just wait for a second. I'm sorry.
Okay.
Just bear with me a few seconds to join the meeting uh, to make sure it's working. Okay, I did see both of you in here. Okay. Uh, so now I don't know why the yeah I did see both of you in here, but I don't know why it's the audio is
Can you
off.
mute? Can you mute one of your devices? Because it's like echoing.
Okay. Yeah. Okay. 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 I will turn off the Blackboard now. The collaborate.